Figure 7.22, initializing multidimensional arrays. This is our first example in which we're going to work with two-dimensional arrays in particular, arrays that have rows and columns, but the techniques that we're going to show you here can also apply to additional dimensions as well. Now, let me go ahead and run this program first so that you can take a look at the output that we're going to be producing. In this example, we have three different arrays that each have 2 rows and 3 columns. And what we're doing is showing you how these different arrays were initialized via their initializer lists. In the first case, for array 1, we had 6 initializer values where the values 1, 2, and 3 were used in the first row, and the values 4, 5, and 6 were initialized in the second row. In the second array, we'll see that we only provided 5 initializer values, so the sixth element, which is the last element of the second row, was initialized to 0. And in this third case, we're going to show you that you can have sublists that don't have enough elements for a given row, in which case the additional elements will be set to 0. So we'll come back and look at that again in a moment. Let's take a look at our source code. So here in lines 11 through 13, we declare and initialize the 3 arrays, array 1, array 2, and array 3. In each case, notice that we have 2 sets of square brackets. Each set represents a separate array dimension. So in some programming languages, you would represent this as 2, 3. In C++, each individual dimension must have its own set of square brackets. Now, when you're using an initializer list to initialize a multidimensional array, normally what you want to do is to provide a separate sub-initializer list for, in this case, each row. So we have a 2-dimensional array, and we want each row to have its own initializer list. So this first initializer list represents the 3 elements in row number 0, and the second initializer list represents the 3 elements in row number 1, which make up the 2 rows of our 2-row, 3-column array. And the index numbers for the rows start at 0, and the index numbers for the columns start at 0 as well. Now, in this second case, we have a single initializer list for a 2-dimensional array, and what's happening here is that C++ automatically takes as many elements as necessary to initialize the elements of the first row. Then it continues at the beginning of the next row, with 4 being the second row's first element, 5 being the second row's second element, and then we don't have a value for the second row's third element, so that one got set to 0, and you can see that here in the output. And then finally, we have a third array where we have 2 initializer sublists, one that contains 2 values and one that contains a single value. The first sublist is used to initialize the first row, so the first row has 1 in its first element, 2 in its second element, and then since we didn't provide an initializer for the third element, that one gets set to 0. The second row has 4 in its first element, and then because we didn't provide additional initializers, its second and third elements are set to 0, and you can see that here in the output. Now, when you're working with multi-dimensional arrays and you want to pass them to functions, just like single-dimensional arrays, you simply pass in the name of your array. Now, typically for multi-dimensional arrays, you'll also pass in the number of rows, number of columns if it's a 2-dimensional array, or if you go into further dimensions, you'll pass in additional numbers that represent the other dimensions. In this case, because all of my arrays have 2 rows and 3 columns, I'm just passing in the array names, and I've hard-coded these loops to operate on arrays with 2 rows and 3 columns. Now, let's look at line 27 because this is important. This function called printArray expects to receive an array which it's going to call A, and the array contains integer constants, which means printArray is not allowed to modify the elements in the array. Instead, it's just going to look at the values and output those values. Now notice that we have 2 sets of square brackets specified for the parameter. That indicates that there are 2 dimensions expected of any array that is passed to this function. The array must be an integer array, and it's going to treat the integers in that array as if they're constant so that it will not modify them in the body of the printArray function. Now, the other thing I want you to notice is that for the first dimension, we didn't specify how many elements there are, but we did for the second dimension, and this is required. And the reason it's required is that in memory in C++, a 2-row and 3-column array is allocated as one long block of 6 integers, where the first 3 integers represent the first row and the next 3 integers represent the second row. So what this number in the second dimension tells the compiler is that every row consists of 3 elements, and that's how the compiler is able to figure out in memory where each new row starts in memory. And so at lines 30 through 37, we have a nested for loop here where the outer loop controls which row we're operating on. So we start counting from 0 for the rows, and as long as the number of rows is less than 2, so we're going to have row 0 and row 1 in this case. And then within a given row, we have a second nested for loop that's going to deal with the columns. And we know we have 3 columns in this example, so we hard-coded it to start counting from 0 and keep counting as long as we're less than 3. So 0, 1, and 2 are the column index numbers. And the way that you access an individual element in a two-dimensional array is you first specify the row in a set of square brackets, then you specify the column in a set of square brackets. So common programming errors for people who are first getting started with C++ are to do things like forgetting to specify the number of elements in the second dimension, and also forgetting to use multiple sets of square brackets, one set for each of the dimensions.